The final measure of the center that we're going to discuss is the mode. To find the mode, we must find the frequency of each value in the data set, and the mode is simply the number which appears the most. In the following data, the mode is 6 because 6 happened 3 times. If no value occurs more than once, the data has no mode. In this table, we have 6 300s, 2 400s, 2 450s, 1 800, 1 940, and 1 1050. So the mode is 300. To find the mode of this data, we're going to look for the frequency of each observation: 25, 26, 17, 11. So the modes are 5 with 2 as its frequency, 6 with 2 observation, and 11 with 2 observation. We say that the data is a trimodal data. The mean is pulled in the direction of skewness. So if it's skewed to the right, the mean is greater than the median. If it's symmetric, the mean and the median are the same. And if it's pulled to the left, the mean is less than the median. Therefore, the mean is not a resistant measure. It is sensitive to the influence of extreme values. If you take 4 tests, the appropriate measure of the center that is commonly used, is the mean, the average of all the scores. Realtors use the median on resale prices of U.S. home because the median is a resistant measure. It is not pulled by extreme values like the mean does. Now, if you have 2 categories, male and female, the data is qualitative, so you need to use the mode as the appropriate measure of the center. Summation notation. If we're adding the weight of 6 people in the group, we can use the sigma symbols, to add those weight from 1 to 6, which means from weight 1 to weight 6. For example, sigma n means we need to sum n. In the next example, we see that n goes from 1 to 4, which means that n will take the values of 1, 2, 3, and 4. And we have to add those values. Sigma xi from 1 to n means to add x1 plus x2 plus xn. I varies from 1 to n using only integers. For question A, we are being asked to calculate the sum of xi. I varies from 1 to 7, which means that we're going to add the different observation from 1 to 7. The first observation is x1, the second one is x2, and so on and so forth until we reach x7. Now, the second step should be to replace the observations by their actual values. X1 is 10, x2 is 5, x3 7, and so on and so forth until we reach x7, which is 11. Now, this sum can easily be calculated with the TI-83 calculator. We just enter the data and add them. I mean, it's not a big deal, and the answer is 68. So that sum is equal to 68. For B, we need to find the sum from 1 to 5 of xi plus 1 in parentheses. So it's going to be x1 plus 1, 10 plus 1, x2 plus 1, 5 plus 1, x3 plus 1, 7, 7 plus 1, x4 plus 1, 9 plus 1, plus x5 plus 1. x5 is equal to 16. 16 plus 1. Now, 11 plus 6 plus 8 plus 10 plus 17. With our TI-83, we will easily find the answer to our sum. It's 52. A is the sum from 1 to 4 of f sub I, x sub I. This is the expansion. The first observation is f sub 1. So it's going to be 3 times x sub 1, which is 13, plus f sub 2, which is 5, times x sub 2, which is 9, and so on and so forth. The last term will be 7 f sub 4 times 20, which is x sub 4. 3 times 13 is 39. 5 times 9, 45. 2 times 10, 20. And 7 times 20, 140. We'll use a calculator to add them. 39 plus 45 plus 20 plus 140. The sum is equal to 244. For B, we're going to calculate the sum from 1 to 4 of f sub I, x sub I squared. So it's 3 times 13 squared. The first observation. The second one is 5 f sub 2 times 9 squared, x sub 2 squared. The third one, f sub 3, 2 times x sub 3 squared, 10 squared, until we write the last one, which is 7 times 20 squared. 3 times 1, 69, plus 5 times 9 squared, 81, plus 2 times 10 squared, 100, plus 7 times 20 squared, 400. Then we're going to use a calculator to get the answer parenthesis, 3 times 169, close parenthesis, plus 5 times 81, close parenthesis, plus 2 times 100, close parenthesis, plus 7 times 400, close parenthesis. And our final answer is 3,912. C asks for the calculation of the sum from 1 to 4 of f sub I times x sub I minus 10 between parentheses squared. F1 is 3, and we have 3 times 13 minus 10 squared, plus f of 2 is 5 times x of sub 2, 9 minus 10 squared, and so on and so forth. Step 3 times 13 minus 10, 3 squared, plus 5 times 9 minus 10, negative 1 squared, plus 2 times 10 minus 10, 0. We don't have to square it. 7 times 20 minus 10, 10 squared. 3 times 9, 27. 5 times positive 1, 5. 2 times 0, 0. And 7 times 100, 700. We get 27 plus 5, 32, plus 700. The answer is 732. Using the sigma definition, the mean is the sum of all the observation divided by the number of observation. Now, in this example, these are the amount of gasoline bought by 6 motorists. The mean will be the sum of all the observation, amount of gasoline bought, divided by the number of motorists, divided by 6. So we'll add 6.2, 10.8, 16.5, 8.0, 18.4, and 4.5, and then we'll divide them by 6. We'll just use the calculator to get the total. We get the total amount of gasoline bought, 6.2 plus 10.8, and so on and so forth. And that amount will be divided by 6. 64.4. And 64.4 divided by 6 is 10.73 to the nearest hundreds.